Good afternoon. This is an introduction to rigid bodies, and we're going to be doing a kinematics problem where we're given a problem of a bars A, B, and BC that are perpendicular to each other, and we're also given a bar BC that is rotating at a given value, and we're also given the value of length and the angle, and we're asked to solve for the angular velocity of the bar AB and determine the velocity of C into components. So first things first, we always classify the question. There's no mass, there's no forces, it's not asking us to find energy or anything like that, so it's gotta be a kinematics problem. We know it's a rigid body because it's asking for angular velocity. One thing we want to do is write down our governing equations, which is VB equals VA plus the R cross omega. And what we want to do is analyze from starting from point A to point B, and then we're going to move our way from B to C, so we could find our unknowns or what we want. But before we do that, we want to identify our constraints. So we could see how point A is pinned in here. It's not going to move, so the velocity is going to be 0. And if we're analyzing at point B, it's only going to be moving in the I-hat direction, only because it's pinned. Point A is preventing it from moving in up and down. And then from point B and C, it has an I and J component, but at an angle. So those are our constraints. And since VA is pinned in, there is none. And we have VC in, as I said, in J and I have, but just in at an angle. And from here, we want to analyze from pin A to from point A to point B. And from here, since it's pinned in, it's gonna not rotate, so it's gonna have 0 velocity. We're given the length from point A to point B, which is negative 2.5 because it's going downwards. And we also know VB is in the I-hat direction. And when we take the cross product of K cross J, since it's moving clock the other way, it's going to be negative I-hat, which the negatives cancel. So we're just going to be left with VBI times 2.5 omega AB I-hat. And then after that, we're going to start analyzing from B to C. And when we analyze that, we know VC has a J and I component at an angle. And we know VB from the previous analyze linkage from A to B, and we know BC is given, and we know the length is in the I-hat direction. So when we take K cross J, I, we're going to get J, and we write our equations and knowns, and we don't know VB, but from what we saw from here, we could plug in. So when we do that, we're going to gather all the J hats and I hat separately, so we end up with a two system of equations, and we solve for VC, and we end up with this as the I and J components, and then we also solve for omega AP. And it kind of makes sense how VC the I components and the J components are the same, because it's at angle 45.